Hi, my name is Dylan Clark, and this video will be explaining loudspeakers and the physics behind their functioning. First off, we will ask the question, what is a loudspeaker and how do they work? Loudspeakers and speakers in general convert electricity into sound. An electromagnet is used to vibrate a diaphragm inside the speaker which produces sound. The inner part of the cone is attached to an iron coil placed in front of a permanent magnet. As electricity flows through the wire, the electromagnet either attracts or repels the permanent magnet, which moves the coil back and forth, vibrating the cone. So here we can see a diagram of a speaker showing the movement of the coil and the magnet. As we can see by the arrows, it shows that the diaphragm of the cone is being vibrated back and forth by the movement of the magnet. Next question. What changes the frequency and volume of the vibrations? The voltage flowing through the coil influences the volume of the sound produced. When the voltage is higher, the coil moves a greater distance, and thus the amplitude of the vibration is larger. The same goes for smaller voltages, which cause the coil to move a smaller distance, therefore making a quieter sound. The frequency of the sound can be influenced by the size of the cone. Larger cones move more slowly when vibrated, and smaller cones vibrate faster. The speed of the vibrations is what controls the frequency of the sound. Here with me now, I have a regular speaker. The simple drawing before shows basically what is inside this speaker. If you look closely enough, you will see that the speaker has two cones, which means there are two coils and sets of magnets inside it. If I raise the volume of the speaker, the voltage applied by the battery in the circuit will be greater. Systems inside the speaker will read through music and determine the frequencies and the notes being played, thus creating the music. Before we get into the math behind all this, there are some terms and equations we need to note. Let's start with some vocabulary. First, we have frequency. The frequency is the rate at which vibrations occur in a wave. Next, we have the voltage. The voltage is the potential difference of a circuit expressed in volts. Wavelength. The wavelength is the distance between successive crests or troughs of a wave. And finally, the period. The period is the time needed for one oscillation of a vibration to pass a certain point. Now let's talk about the motor principle. The motor principle states that a current-carrying conductor that cuts across an external magnetic field lines experiences a force perpendicular to both the magnetic field and the direction of the magnetic current. This is important when talking about the movement of the electromagnet relative to the permanent magnet. The coil, which is made of wire in this case the current-carrying conductor, and is cutting across the external magnetic field created by the permanent magnets, thus exerting a force which drives the cone to vibrate back and forth. Finally, there are some equations to note. The first one, for calculating voltage, is V equals lambda F. Next, to calculate the period is T equals 1 over the frequency. And finally, for calculating the speed of the wave is V equals lambda over T. Okay, now I will be showing basic calculations. The first question is, if a note is played with a voltage of 25 volts and a wavelength of 200 meters, what is the frequency of the note? We'll start by writing out what we know. So what we know is that the voltage is 25 volts and the wavelength is 200 meters. And what's required is the frequency, which we don't know yet, but we'll go to calculate that. We're going to use the formula F equals V over lambda. This is a rearranged version of the V equals lambda F formula. So from calculating it, the frequency is equal to 25 over 200. Therefore, it is equal to 0.125 hertz. Now, using the frequency calculated in the last example, we will now calculate the period. The formula for calculating the period is T equals 1 over F. Since we know from the last example that the frequency is equal to 0.125 hertz, we can use this formula to calculate what the period would be. So that's 1 over 0.125, so the period is equal to 8. For my final calculation, I will use the third formula to calculate the speed of this wave. Since we know that the period is equal to 8 seconds and the wavelength is equal to 200 meters, we can use these to calculate the speed of the wave. Using the formula V equals lambda over T, we find that the speed of the wave is equal to 25 meters per second. That is 200 divided by 8 is equal to 25. That's it for the calculations. Here's some screen recordings explaining the principles behind the physics of loudspeakers.